Hello everyone, Geophysicist Stefan Burns here. There's a lot that's been happening this year in 2025. It has been solar maximum, meaning that the sun has been at the peak of its activity, the strongest solar maximum since the early 2000s, this being solar cycle 25. It's also been the sixth biggest year in recorded history for seismic activity, primarily because of that magnitude 8.8 megaquake that struck off the coast of Kamchatka, Russia, just north of Japan, near Alaska, in July of this year. But there's also been tons of magnitude 7 earthquakes. So a big year seismically. We've also been having some very notable planetary geometry. We have a Saturn-Neptune conjunction that in fact is exact today from a heliocentric standpoint. We'll look at that. So in terms of the overall solar system, right now, today, the 13th of December, Neptune and Saturn and the sun are perfectly aligned. And in fact, Mercury is on the other side of the sun participating in that alignment with a very, very close degree alignment to it. We also have a very big alignment coming up early January of 2026. So there's been some notable planetary alignments already. Remember that megaquake I mentioned, that magnitude 8.8? There was a big planetary alignment that occurred involving the Earth within about 2 weeks of that big megaquake. So there's a lot that's been happening. The second biggest ever and longest duration gamma ray burst hit Earth on July 1st. We had that megaquake on the 29th. So just in general, everything's been super, super active. And I don't think that's about to end. There are signs in the Earth, with the sun, and with the planets, just overall with the cosmos, that something big could be coming. So that's what we're going to examine in today's video: the space weather factors, the planetary alignments, and the earthquake risk for Japan, because there's anomalous earthquake activity that's occurring right now that's suggestive of a megaquake. I've crunched the data. I'm going to show you that. Let us start with our sun. Here we have our coronal hole on the sun, and this is the first thing to know as it relates to these space weather factors. We have these structures called coronal holes, and these are areas in the outermost atmosphere of the sun where there is a lot of high vibrational plasma. It's very high temperature, millions of degrees Kelvin, where there's a deficiency in that. So effectively, imagine like our upper atmosphere had a big gap in it. That is what a coronal hole is for the sun. It shows up dark on our 193 angstrom view here as a result of there being less plasma there, lower temperature, lower density. The magnetic field extends out from the sun, out of these coronal holes deep into space. So whereas normally it kind of loops back in, it's a little bit more confined. It's a complicated picture in general. But with these coronal holes, you have these open magnetic field lines that extend out. And Earth at 1 astronomical unit is very close to the sun. So you have Mercury, Venus, Earth all in that 1 AU range. Mars about 1.5 or so. Jupiter's at 5 AU. Saturn's at 10. Uranus is at 20. Neptune's at 30. And even then, these are still distances fairly close to the sun if we start looking at a lot of the trans-Neptunian objects like Sedna, like Eris, or we talk about where the comets that are flying into our solar system, where they come from way, way, way out there. 1 AU is very close. So when we have these coronal holes sweep by, we actually have one right now hitting us. This section right there is hitting us with this high-speed stream. So solar wind right now, the velocity is over 600 kilometers per second. We're going to get in a few days another burst from this trans-equatorial portion there. When that sweeps over us, we form a direct magnetic connection with the sun. And the force of electromagnetism is by far a much stronger fundamental force of the universe than gravity. Gravity, of course, is important. Can't discount gravity, but the moment you start talking about electromagnetism, the game changes, right? It's very easy to pick up a metal paper clip with a magnet off your table, let's say, because gravity is effectively negligible in comparison to the force of electromagnetism. So when the sun starts to interact with the Earth electromagnetically, it can do a lot of things. We also have this planetary alignment. And we're going to get over into what this convergence is, because we have this large coronal hole that's been basically provoking a lot of high magnitude earthquakes. That's at least a very strong correlation, and you can make that statement and have quite a bit of data behind it. Going to be in Earth-facing position, just having swept us with its high-speed stream during this notable planetary alignment that we have coming up. So let us see this planetary alignment. It's in fact already starting to come into play. So here we're looking at the sun. This is our past 24 hours. It's called a coronagraph. And so the sun is this white circle there. They put a disk over it so we can see the solar wind and any solar storm outflows. Like there's a solar storm that launched off from the sun. What are these two bright objects? Well, those are Venus and Mars, both on the other side of the sun, soon to perform a superior conjunction. And so Venus shows up very bright because it's very close to the sun, has a very thick atmosphere. Mars is further away and doesn't have much of an atmosphere, so it shows up quite a bit dimmer, but we still see it very clearly there. And if you look closely, you'll notice that that's not a star, because we also see the background stars here. You'll see that this is moving slower than the other background stars, because it's also moving forward in its orbit. Venus is moving very quickly, going to soon become an evening star, so that's why she's moving faster than the sun, and she's catching up to the sun. We're about to have them both go conjunct on the other side of the sun, which is a planetary resonance that occurs every 2,338 days or so, approximately. This time we have that also occurring with Jupiter, and this is also going to be happening with the solar conjunction. They're superior conjunctions, or cazimi. So we have a double Venus-Mars cazimi with the sun, while Jupiter is in opposition at the same time. In addition to that, we have a ton of earthquake activity off the coast of Japan. Let us give that a look. So here we can look at our USGS latest earthquakes, and this is for the past month, earthquakes greater than magnitude 2.5, and we see that there are two distinct zones of swarming here. And in fact, this 30-day view is not going to fully capture the earthquake swarms in that zone. So let me put in a custom date here. Let's put November, and we'll just put the beginning of November, because that's when this earthquake swarming really started for Japan. And we'll put magnitude 4 for our earthquakes, and you'll see what I'm talking about. So we punch in on Japan. Here are those two zones of swarming that have been occurring over the past 6 weeks. And if I sort this by highest magnitude and only list earthquakes on the map, we see a magnitude 7.6, we see a 6.8, a 6.7, a 6.6, a 6.4, magnitude 6, tons of magnitude 5s, a huge list of magnitude 5 earthquakes. This is 6 weeks right here, folks, only 6 weeks. And then we have hundreds of magnitude 4s. So this is not normal. Now, Japan does get a lot of seismic activity. It is one of the places on the planet that can have earthquake swarms that form. But typically, earthquake swarm will be magnitude 4s. Magnitude 5s at the top. Sometimes they're often less than that, like magnitude 3s and stuff. And they will last for like 18 months, 24 months. This is 6 weeks of activity here. And the real progression is not just that we had this 7.6 and everything followed. It's actually quite a bit different. So it's going to be easiest to keep on largest magnitude for you. But what we had happen was we had a whole bunch of magnitude 5s start up in this swarm early November. And then we had a magnitude 6.4, this one right there, and a 6.8 pop off same day on the 9th of November, as you see there, right? 9th of November, okay? Then we put out an alert saying, okay guys, we have a risk of a megaquake as a result of this. Actually, back when it was just the magnitude 5s, I was saying we have a risk of a high magnitude earthquake. Once we had those magnitude 6s, it definitely looked like the megaquake risk went up. This was a month before the magnitude 7.6 ruptured. We see that was on the 8th of December. Then the Japanese have officially come out and said there is an elevated risk of a megaquake occurring in the near future, because this activity is very reminiscent of when there have been previous high magnitude earthquakes like magnitude 8+ and the foreshock activity that they had. After this 7.6, we've had a 6.6 aftershock. You notice that that's the same day. And then just recently, 4 days later, is 6.7. This is weird. Typically, if you have a high magnitude earthquake, we'll use the 7.6 here. We think that the strongest aftershock is going to be 1 magnitude less, okay? So for 7.6, that's perfectly 6.6. We had that the same day. We had that aftershock the same day. That should be, in general, that should be it. Well, instead, 4 days later, we had another aftershock, this time though, actually bigger. And that's not including any of the activity here, which at its highest had a 6.8 and a 6.4. So you take this combined, and this is very anomalous, and then you add in the fact that back in March of 2011, we had a magnitude 9.1 in this location, just in the same geologic setting, just nearby and in geologic time, effectively right on top of each other. That is very worrying. So there is a very high megaquake risk at this moment in time. And we have some data to look into there as well. So let's talk more about these coronal holes on the sun, because they are a very important feature as it relates to what we're talking about here. And there's one coronal hole in particular that has really been active in causing a lot of these sort of earthquakes. It's basically been connected to all the big earthquake activity for a while now. So I'm just looking to pull this up. And actually, I believe that's it right there. So let's see how this one looks right here. And here is that big coronal hole. You see that this is for December. Okay, so this is December 4th right here. Huge sunspots on the sun. Those have now just rotated out of view. This coronal hole has been active on the sun for months, and it goes all the way back to before July when we had that magnitude 8.8 megaquake. It's transequatorial, meaning that the high-speed stream that it emits will flow by the Earth, and that magnetic field connection will occur. The solar wind velocity will go way up. The density around the Earth goes way down. The environment around the Earth, the space environment around the Earth, of course, affects the Earth. Plate tectonics is the main system that governs earthquake activity, especially like the Ring of Fire, right? The continental plates moving, sliding past each other, all this, right? The forces build up over time because there's always new plates being created, new crust being created at the mid-ocean ridges. You can't ignore plate tectonics. This is the fundamental system for earthquakes and the Earth geophysical system, right? But what is influencing plate tectonics? Well, it seems that the space environment itself influences plate tectonics due to a change in the amount of energy, material, and mass and pressure around the Earth. Because what we see time and time again now, we have decades of research on this, is that coronal hole high-speed stream impacts have this ability to load the Earth successively over many months with energy that then eventually seems to rupture with high magnitude earthquakes. And that's what we've seen this year with the magnitude 8.8 and also a lot of other magnitude 7+ earthquakes, including that 7.6. Again, look at the date here. This is the 4th of December. We're in the high-speed stream. That then continued on. The solar wind density dropped anomalously low. We had that 7.6 earthquake pop off in Japan, showing that there's now a resonance between this coronal hole and Japan, whereas a few months ago, we had a resonance between this coronal hole and Kamchatka just slightly to the north. We can look at our data here, our seismic activity data, so you can really see what I'm talking about, and this is pretty interesting. So here we have our seismic activity for 2025, and we see different levels: low, moderate, high, very high, extreme, okay? You see, we've had a lot of earthquakes hit that extreme level. And here is our recent time frame. And it's really this section right here I want to focus in on, okay? So this was that megaquake, magnitude 8.8. We had a lot of other activity around it, magnitude 7s. You see just a whole cluster of earthquake activity here. A global seismic burst is what you can call that. Because what we see is that there are these rhythmic trends of seismic activity. And one of the key things is in these, at least for 2025, in these zones where we've had low to moderate activity seismically, that's when the solar wind density has stayed very elevated across long periods of time. So this entire time frame, the solar wind density was effectively really high, and it has really only during those specific times where it did drop down temporarily that we had these big earthquakes. It's really wild if you examine the data. Same thing occurred right here. Solar wind density stayed pretty high. It did drop right when we had that 6.8 in Japan, 6.4. That was kind of like the one time it dropped out. Then it went back up, and look, our earthquake activity is low and moderate. But look at the frequency here. You get this perfect rhythmic spacing between these high magnitude events, just like that. See how that's almost exactly the same spacing each time? That's because that spacing is 28 days. And these coronal holes on the sun take 28 days to rotate around because the solar rotation period is 28 days. So you see it reflected in the earthquake data itself, where you have this 28-day periodicity of the highest release of seismic energy on the globe. So as this relates to planetary geometry, that is coming up because look, we just had this burst. A month afterwards, it's going to be the beginning of January. So let's look at the planetary geometry that we had beginning of January, because this has been implicated also with high magnitude earthquake activity. We can look at that right here. Here we have our application, the solar system scope, which allows us to see the position of the planets and more. And we see, for example, the Earth right here. And I've been talking about this planetary geometry for more than a year now, because it's very notable. It's the first time we've had this specific planetary geometry since 1936. And we see it very clearly right here. Mars, Venus, Mercury, Sun, Earth, Jupiter, all in a line. So the perihelion of Earth, the closest approach to the Sun that it has every year, is on January 3rd. And then we have this alignment with Venus and Mars doing their double Cassini, superior conjunction with the Sun, everything. That is going to be on the 7th of January, roughly. You see that this right here is set for the 11th of January, but it really looks nice. Let's even zoom it around like this, maybe even top-down view right here. It really looks nice on the 6th to the 9th. But you see that there's kind of a time range here. Even going from the end of December to the middle of January, you get this alignment. But it's really exact around the 6th, 7th, 8th, and 9th of January. And then the opposition of Jupiter, the part of the year where Jupiter's on the other side of the Sun as viewed from Earth, is on the 10th. So this is 3 celestial events combined. The perihelion of the Earth, the Mars-Venus conjunction on the far side, which is a 1 in 6.6 year event, and then the Jupiter opposition, all coinciding in time. You also notice that we have this alignment here between Neptune, Saturn, and the Sun, heliocentrically. Well, if we go back to today, the 13th, actually let's do this, we see that we have that exact conjunction between Neptune, Saturn, the Sun, and Mercury right now. So it's not just one planetary alignment that you look for. It's when there's multiple that overlap and they're all significant that you start to raise your eyebrows. Because if you look back through time, significant planetary alignments, especially when there's a clustering of them, seem to provoke certain events to occur on Earth, whether it's volcanic activity, earthquakes. There's also connections with solar activity and solar storms. For example, there was a really notable alignment very similar to what we have coming up in January, just days before the Carrington event. It's actually the same Mars-Venus-Earth alignment, but this time Saturn was also participating. So it's very interesting. So we have this alignment right now with Neptune, Saturn, and the Sun and Mercury simultaneously. And if we go back, let us go back to right before, or actually right after the megaquake that occurred. You'll see a very interesting alignment. Megaquake was on July 29th. Okay, so you actually see that this is already active. But here we have the planetary geometry. Let me move this forward. See if I can get that right there. Here's the planetary geometry on July 29th. We have Neptune, Saturn, Earth, and Mars in a line like this, as then you have Uranus and Pluto in these 60-degree aspects to that line. And it's really quite striking because Mars archetypally represents energy and slicing and dicing and breakage. Earth, of course, is the Earth. Saturn is representative of structure and matter and material. Neptune is the dissolving of things, also of the oceans and more. Pluto represents powerful underground subterranean events. Uranus represents sudden change and disruption. That basically is perfectly archetypally resonant with there being a big underwater earthquake, just like we had with the magnitude 8.8 megaquake. This was the planetary geometry the day of that megaquake. So there's a lot that is happening, and I wouldn't put out this forecast if there was nothing to talk about. But the thing is that we have this anomalous earthquake activity right now off the coast of Japan. So here's the data. I crunched the data. This is the seismic energy release comparison between zone 1 and zone 2. Here we see zone 1 and zone 2. And here we see the comparison of seismic energy release for both of those zones combined compared to the foreshock activity before the magnitude 9.1 Great Tohoku earthquake, March 11th, 2011. The biggest difference between these two data sets is that this foreshock activity was about a week of data, and this time what we see here is about 6 weeks of data, because we've been having this anomalous activity for 6 weeks now, whereas back in March of 2011, it was a sudden burst of activity, and then we had the 9.1. So that's the biggest difference. Keep that in mind, but there's a lot of similarities here that's worth meriting a look. So we see that zone 1, where we had the 6.4, 6.8, was pretty similar in terms of its seismic energy release as to this new zone of seismic activity until that magnitude 7.6 occurred. And that really raised up the total seismic energy release for Japan quite a bit. You combine them, you see that on all counts, there has been more seismic energy release measured in gigawatt hours. This is a log scale for both of these. For what's happening now than there was before the magnitude 9.1 earthquake in Japan. So we see that we've had more magnitude 4s, more magnitude 5s, more magnitude 6s. The magnitude 7 was stronger. The foreshock that occurred before the 9.1 was a 7.3. We had a 7.6. So we had right here 5,200 gigawatt hours of seismic energy release, and there it's 1750. That's 3 times more. So we know that the strongest earthquake on record is the magnitude 9.5 that hit in 1960, South America, right? Chile, Peru, that whole area, right? 9.5, magnitude 9.5, huge earthquake. 9.1 is quite a bit smaller than a 9.5. We also had a 9.2 that hit Alaska in 1964. Those are both on the Eastern Pacific side, effectively. Well, this is the Western Pacific. We've had the magnitude 9.1. We haven't had a really reciprocal balance of energy with that 9.5 event. And so if this scaling factor, I don't know if this megaquake is going to happen, but I think it's just a much higher risk based off of the solar activity lining up with the planetary alignment that I just showed you, right? Because the increased gravitational forces, the planetary alignment seem to work in other unknown ways as well. And then we already have very clear, strong evidence of solar activity, especially coronal hole high-speed stream impacts and low solar wind density being very well correlated with high magnitude earthquake activity. If the scaling factor is the same, then we're looking at earthquake 3 times stronger than the 9.1, and that would be a 9.4. So a 9.2 is like 1.5 times stronger, a 9.3 is 2 times stronger, a 9.4 is 3 times stronger than a 9.1. I don't know if that scaling factor is going to hold, but it is the same geologic setting. It's nearly the same time frame. This isn't 1,000 years in the future, so things have changed. This is only 14 years in the future, effectively. The geologic factors are all basically identical, but the solar cycle factors are a bit different. Back in 2011, it was the end of the ascending phase and the beginning of solar maximum for solar cycle 24, which is weak. This time it's solar cycle 25. We're at the very end of the maximum, the beginning of the descending phase, so tons of energy has been pumped into the Earth already, right? It's not like we're just beginning this loading cycle. We've been loading the Earth up with energy now for a long time. And we're starting to start that descending phase, which is when we often get high magnitude earthquakes. And you have this seismic activity, you have the planetary alignment, it's all kind of converging together. So I think that something big could be coming. I hope that I am wrong, but based off of everything that I know, the research I've done, and what we've been tracking here publicly on the channel, you can verify all this yourself, there's certainly a much higher likelihood. We forecasted the magnitude 8.8 megaquake months in advance. I was getting a sense, a feeling that we were overdue for a megaquake because the last one we had before that, a megaquake is an 8.0 or greater, was back in August of 2021. So we are 4 years overdue. We typically get one every year. So I started making videos about a megaquake risk a few months before the 8.8. 3 days before, I put out a video saying, here's the first area of highest seismic risk, considering all the factors, and boom, it popped off. We had that planetary geometry I mentioned. We also forecasted a magnitude 7.6 earthquake that just struck Japan because of that anomalous activity with the 6.8 to 6.4. There's been reciprocal action with the earthquakes in Kamchatka and also South America. So we've been forecasting those earthquakes fairly accurately as a result of that. The main aftershock for Kamchatka is a big magnitude 7.8. That was well forecasted here on this channel. So it was a bit of a track record. And just based off all the factors, I think there's a much higher risk factor right now for Japan as a result of all this. So that is the video. I hope that nothing happens, but I don't think we can rule it out. Earth is effectively supercharged right now from solar maximum, from all the solar flares that we had. We had tons of solar flares from these sunspots, charging up the global electric circuit as those light photons hit the ionosphere, charge it up, and then this coronal hole, which has done many rotations and it's linked up to that magnitude 8.8, a lot of the magnitude 7s, it's negative polarity, transequatorial, almost certainly it's going to be back in the same position at the beginning of January. We're going to be in that high-speed stream, low-density solar wind structure right as that planetary alignment is forming in January. And we have this megaquake risk. I would say that the megaquake risk for Japan, because of this activity, actually goes out a few months. So it's not just the next couple days. Because of the 6.4, 6.6, and the 7.6, the 6.7, the 6.6, all the activity, this earthquake risk enhancement, I would say, goes all the way out till February. We have to wait until January to get a sense if it needs to get pushed out even further. But as of right now, definitely extends out to February, because sometimes we get foreshock activity and then there's like a month or two and then it happens. So it's not just, oh, it needs to happen within 2 days. It can be like 2-3 months delayed, but it certainly was foreshock warnings for anyone living there. So this is all within the same time frame. So thank you all so much for watching. I've been your host, Stefan Burns. If you like this video, then smash that thumbs up button. Help this channel grow. It really helps out. And this is what I do. I cover everything that's happening with the Earth energetically. We look at earthquake activity. We look at volcanoes, geomagnetic storms, severe weather, space weather, solar activity like solar flares, coronal mass ejections, what's going to hit us, what's not, planetary resonances and alignments, interstellar objects like 3i Atlas, comets, cosmic forces, all that and much more. I release videos almost daily, so I hope to see you around. And wishing all of you the best. Happy Saturday. Have a great day, and I'll see you all in the next video.